gonna have to leave the class meeting a little early because oh, interesting. Congratulations to her. Somebody's headed out to a wedding later. All right, that's fine. What I want to do today is do a little bit of practice on what we just did yesterday. That fantastic stuff we did yesterday that you guys just love so much. Like, let's do that forever. And then the rest of the time is going to be devoted to any questions from chapter 1 through 5. Don't worry about 6 and 7 too much at the moment. If you have questions on 6 and 7, maybe hold on to them closer to the end. But so are there any questions before we get into it? Let's do this. Any questions from 6 and 7 that you guys are working on before we do that worksheet from chapter 7 together? I love you're all like 6 and 7. You're funny. All right. All right. I guess not. So let's do this. So I had that handout that we barely looked at yesterday when I tried to, in a last ditch effort, to show you it wasn't going to be as horrendous as it seemed it might. Here's that handout. Let me see. Did I unblock it yet? No, you didn't. You doofus. All right, hold on. Leave student view. So if you go to unit 7, and give me a minute, and you will see something called CLT practice. So the whole thing about changing standard deviation and sample means and n greater than 30, all of that is in chapter 7. Right? So don't try to do any of that stuff in chapter 6 because number 1, it's chapter 7. And number 2, you don't need to use chapter 7 stuff in chapter 6. It's not the right setup. All right. So let's do this, and then we'll open it up to questions related to the midterm. Can you guys find this? Can you guys see this CLT practice sheet?
I can't see it.
You got to refresh Canvas. I just unlocked it. Refresh. Don't do it. So it's right there, CLT practice. You only see these 2 things because these other 2 things are not published. Is anybody able to see it yet? You guys, anybody?
Yes, I can see it and download it.
Okay. All right, I'm going to open this.
I can see it, I'm printing it out.
Okay, cool. So let me open it a different way. Scheisse, where are you? CLT, chicken, lettuce, tomato. That's what CLT stands for. All right, it doesn't exist, Jeff. That's neat. Let's download it. Now it exists. Now it exists. Stay with me now. We just started. You're already like, I'm over this. All right. So let's take a look here. Oh my God, I got so many tabs open. Get it out of there. All right, we're hearing a little too much from somebody's life. There we go. So we sort of looked at this a little bit, right? This is bone density stuff. By the way, real quick, that's my office behind me. That's a picture I took of my office. I miss my little office. I got my little voodoo doll up there. Anyway. So look at this problem. All right. There's not much build up here, correct? There is just 2 sentences. What are the most important things that you see in the situation here?
the average and the standard deviation.
Good. So we know the mean and the standard deviation. What are those?
2.9 and 0.31.
Holy crap, Jeff. There we go. Okay. All right. Now somebody else tell me there is a third thing. It's not a number, but it is very important that they told us this.
That it's approximately normally distributed.
So do I need n greater than 30 to know that I'm working with a normal distribution? No, because they told me that the individual bone densities are already normally distributed. All right, so this number right here, this standard deviation right there, that is how individual bone densities are distributed. Is that all right out there? Who can I hear? I can hear somebody. Oh, there he is. Pop! All right. Everything we've done through chapter 6, not everything, but in chapter 6 especially, the standard deviations were about individuals. So if I had a standard deviation of test grades, that would be how individual test grades were spread out. So the big deal with chapter 7 is if I take a sample and ask questions about the sample mean, I need to know how samples are distributed. I really want this to make sense. We all survived Florida yesterday. So let's not go back to Florida. All right, screw Florida. All right. I did my time in Florida when I was younger. I escaped. This first problem, when in fact, let's just do this first problem. This all man. I started doing the next step here, but I want you guys to be with me. So how would I do this first problem? This first problem is a chapter 6 problem. There's no samples being taken, whatever. So it says, find the probability she will have a density more than 3. Can you guys draw that picture for me? Don't, or for yourself. You don't have to send it to me so I can put it on my fridge. That's correct. Let's see. All right, so what's going to go right in the middle?
2.9.
0.9. And for this problem, what data point am I going to put down on the picture? What's the question really? Probability that x is
3,
what?
more than 3.
Greater than 3, exactly. So I want to put 3 down here. So it's over there somewhere. And then where am I going to shade?
To the right.
Good, above 11. So I know we haven't like done this like a ton, obviously. It's the summer, we barely do anything a ton. But does this feel familiar? I mean, right? We put the number down, we shade the area we want. What's the next step I'm going to do before I can find that area? What do I want to use to look up that area?
X minus mean.
Yeah, because I want to use what? I want to use the what chart?
The z-score.
Yeah, so I got to make a z-score. I got to make this into a z-score. So I really want, listen, stay with me. If I know how many steps up that is, I can figure out how much area is further than that. I just have to know how many steps up it is, right? So you guys remember the 68, 95, 99.7, the 68%, 95%? The z-score chart is that with a lot more detail. It's not just one step up and down, 2 steps up and down. It's any steps, any direction, whatever, right? Stay with me now. So that's why the z-score chart works, is because if I know how far from the mean I am, I know how much stuff there is on either side of me. Because I know the mean is 50% and I know it's normal, so I know exactly how much area I gain below me as I move up. That's what the chart is all about. So how do I make this into a z-score? Somebody already started telling it to me. X minus the mean divided by
Standard deviation.
deviation. So it's always your data point minus the mean. The mean's always got to come second. And in fact, you know the z-score is going to be positive, right? You with me? Because it's above the mean. So if you get a negative z-score, don't just keep going. You know it's wrong. Divided by the standard deviation. Okay. So don't say anything. Just take a second and figure out what that is. I think it's 0.32. What, did somebody get it?
0.32.
0.32.
322.
Oh, okay, so 0.32. I like it. So remember always 2 places for z-scores because the chart only goes out 2 places. All right, now, what's the next step?
Look on the chart.
Good. So that's the whole reason we made a z-score, is so I could use my chart of answers, right? So I'm 0.32 steps up. It's not very far up, but let's see how much area that means I have below this.
0.6255.
Does that sound right to everybody else? Let me see if I can open up my z-score chart. Hold on. Oh, there they are. All right, so what was it? 0.32. Can you guys see my z-score chart? Yes, okay. So 0.326255. I love it. So that's down here, correct? All right, now listen. It's summer. I know concepts are flying out of my mouth, right? But try to connect things here. The z-score tells me where I am. Well, the further away from the mean I am, the more area there should be on one side or the other of me. Does that make sense what I just said? No? If I'm at the mean, there should be 50 on both sides of me. Is that right? In a normal curve. Yes? So if I figure out the z-score and I know how far away from the mean I am, that's why the chart exists, because there's going to be an exact amount of area that's on either side of me. I just have to look it up in the chart. I really want that to make sense. The z-score is how many steps away, how many standard deviations I am away, and that translates into an area below me or above me or whatever. Now, so have I found the answer to the question?
-1.
Good, 1 minus that. So I got to do 1 minus 0.6255. You can do it in the calculator, or you can use my nifty little. Is that all right? That's still relatively new, but do you guys feel somewhat comfortable with that? That process?
Surprisingly, yes, much more than the earlier chapters.
All right. Oh, okay, cool. So you're told it's normal, you're given a mean, you're given a standard deviation, and you're asked a probability question, right? Let me see if this helps out. This helps out fewer people than I think, but I'll just try it here. We were given an X score, right? We were given the score 3, correct? We want to change that into a Z score, so then I can look it up and get the percentage, the probability. That's the basic, like the traditional Z score problem. That's how it works. What about the problem that's a percentile? Don't I just do all this backwards? I'm given a percentage, I look up the Z score, and then I put it in that backwards formula to figure out X. So it works both ways. It's nice. Okay.
Just real quick question.
Yeah.
So when they're asking like probability of X greater than 3, or if it was greater than or equal to 3.
So this is the thing that came up yesterday.
Oh, okay.
Any continuous distribution what is, so for example, what would the probability of x equal 3? What would that be?
0.
0. There you go. So that's why if I put a line here, nothing changes because that does not add any area.
Right. Okay.
Look, that's a great question.
Cool.
Could be related to a question, I don't know, that might be on like a test that's coming up. I don't know.
I have a question that it does go a little bit back to chapter 5, so I apologize, but like continuous and uniform. So with the uniform, you are putting that the or equals to on it, but with the continuous, you're not.
Not necessarily. No. If you look at the problems I assigned, they don't put lines underneath all the time.
Okay.
They don't matter. Yeah. And real quick, just to be sure you understand, uniform curve, uniform distribution is an example of a continuous distribution.
Okay. That makes more sense. Thank you.
So any continuous distribution, what does continuous mean? How many values could it take on? What does continuous mean?
Infinite?
Infinite number. So so any single specific value would be 1 out of infinite, which is why probability x equals something is basically 0, because it's like 1 out of infinity.
So could you have
If
said,
we enter 0.9999, are we still correct? Sorry to interrupt.
No. That would be incorrect. It would be like 0.000, write an infinite number of zeros and then put a 1. Yeah. Go ahead, Miss Fosselman.
so for that, where you put the p as x or greater or equal to 3, could you have just put x is greater than 3 and that
No,
would
that's
have
what I
been-
had originally, and then I drew that in when Matthew
Okay.
asked this question.
So either way is fine.
There it goes.
Okay, thank
Yeah,
you.
because it's continuous. Yeah. Okay. Maybe. Okay. Now in part B, there are 2 things that will happen in a normal z-score problem that tells you it's kind of like the next level. If they take a sample of size something, and then they ask you a question about the sample mean, did both of those things happen in part B?
Yes.
We took a sample, and they're asking me about the sample mean of those 22 women, right? So doesn't it make sense? I want this to make all the sense in the world. The standard deviation they gave us, why did it work in this problem? Because that is a standard deviation for individuals. And how many people were we looking at in part A?
All of them?
No, if we randomly select
Oh, just one.
1, so doesn't that line up? I want to use the standard deviation for individuals when I'm asking a probability question about an individual. When I'm asking a probability question about a group, I need to get the standard deviation that's for a group. I really, really, really want you guys to get this. How do I convert the standard deviation they gave me into the one for a group? It's this formula. By the way, all right, I always forget to say something about this. What is there a division happening right? What I'm circling around right here? I really want you remember when we talked about the calculator gave us, I'm over here now, you can see where I am. The calculator gives us sigma. Does anyone know how to say that correctly? How do you say this?
Would it be sigma sub x?
Good, sigma sub x. It's a subscript. It's not divided by none of that shit. So what is this? This is sigma sub x bar. So this means this, now watch. This means the standard deviation of the individual data points. This means the standard deviation of the averages of groups of data points. I know. So if I have a question about an individual, I want the spread of individuals. If I have a question about a group, I better have the spread of groups. I want to know how spread out the groups are.
So would it just mean like the standard deviation to the sample mean?
No, it's the deviation of the sample means.
Of the sample mean. Oh, okay.
Let me try this. Let me try this. I tried this yesterday, but this is really important. When we drew this picture right here, right? What does it mean? Like, what is this person right there? Or I just gave it away. Isn't this one person? This picture is individuals. And I just want to know, what's the probability that this woman is one of the people in here? In fact, I don't think I've said it that way ever. So this is exciting for me. I mean, not even for you guys, just ever. All right, this is something that's in my head that I never put out there. This problem has all the individual women all here, and the problem is, what's the probability that the woman is one of the people in here? Well, what is it? The probability came out to be, did we figure out the, yeah, there it is, Jeff. About 37.5%, right? Which
Isn't that still
means,
quite high?
sorry?
Isn't that still quite high of a percentage?
Yeah, there's a 37.5% of all women, I guess I didn't give an age reference, of all women have a bone density greater than 3 grams per centimeter squared. Don't worry about the units, by the way. I mean, it's all medical crap, but are you guys, is that all right? So I don't know how you gauge what's too much or not enough. 2.9 is the mean. And we're only, remember, we're only how far above the mean? 0.32. We're like 1/3 of a step up. So it makes sense there's still a decent chunk above us. Does that make sense? I really, no, watch. I know. But at the mean, it's 50% above, right? Of course, the mean cuts it in half, correct? The minute I start moving up at all, doesn't that number go down, the amount that's above us? Does that make sense? All right, I don't know. Let me draw here. The mean cuts things in half. So there's 50% above the mean. The minute I have a person that's moving up, doesn't the amount above them go down? So if we go this many steps up, we figured out it leaves this much area above it. That's what that means. That's why the Z-score chart exists, because if I know exactly how many steps up I am, I know exactly how much area is where. Okay. And I'm sure you guys understand there's 2 levels to this. There's the level of just nuts and bolts, can you do a problem? And then there's a level of what does all this shit mean, right? Okay. So I'm sorry, I started to, hopefully you guys understand what's happening here. Let me erase this so I started this over. All right, so this problem, what told me in this problem that I had to do this first step? What told me that? Why am I doing this? Why didn't we do this up here?
Because it said sample.
Good, I took a sample and
Sample mean.
asked the question about the sample mean. If those 2 things happen, you need to get the standard deviation for groups because you're working with a group. Does that make even like this much sense?
So we have to recalculate the mean essentially.
No. You got to recalculate the standard deviation. So when they give us the standard deviation, that is for individuals. That's why the first problem was relatively easy, because it was a question about an individual. Oh, cool, I've got the standard deviation for individuals. Now, part B is, what about this group? I'm like, oh, shit. They didn't give me the freaking, oh yeah, I can do it. So let me do this. This is 0.31 divided by the square root of what?
The mean of the sample of 20.
No, come on, no.
The number of people?
Yes, and how many people are in a sample in part B?
22.
There you go. That's it, right? That's what N means. N is just the number in your sample, or the
So-
number you're looking at.
So even though in the top,
the mean and the standard deviation apply to? Because it says females. So you don't have to change it because even like you're talking about one person in a population, and then you're moving down to talking about just a sample. Because
no.
like you said, like, oh, this is for an individual, but
Yeah,
the numbers at the top are not.
Really want to make sure you get this. You almost got it. So up here in part A, we're talking about one person in a population of individuals. Part B, we're talking about one group in a population of groups.
Got it. Okay.
So when I draw this picture, well, real quick, what is this? Somebody do that real quick.
I got 0.066.
That sounds familiar. I don't know. I've used this handout for so many instruments. I almost remember all the numbers. That does sound familiar. Now, when I draw this picture here, I am drawing the picture that represents all the groups of size 22 graphed. This picture was all the individuals. To be honest, this picture should be a lot skinnier. Only get, if you guys remember, but who gives a shit? When I'm drawing a little picture for myself, it's just sort of a visual of the
Does
problem.
that say root 22?
Definitely.
Okay, sorry, because it looks so close to the lowercase sigma.
Oh, I see. Okay. Yeah. Went a little crazy with my square root symbol.
Got to get the V in there.
Is that better?
The lowercase sigma looks strangely phallic to me, but maybe that's just.
Well, that's a whole thing. I'm not qualified to discuss that with you. Now, what goes in the middle of this picture?
2.9.
2.9. I like it. Right? The mean stays the same. And of course, the question I'm curious about, more than 3, correct? So I'm going to still put 3 here. And I'm going to still, so the picture looks exactly the same, really, right? And the work is going to look the same. Look, now I want to make a z-score, right? Now here's where things, I really don't want you to, x bar minus the mu divided by the sigma of x bars. So it's always our data point minus the mean divided by the appropriate spread. So my contention is the z-score formula never changes, and we'll see if you believe me later this semester. So I still would put 3 minus 2.9, but what am I going to divide by now?
0.66.
0.066.
Oh, yeah.
And I believe that will be 1.38. I don't know. 0.1. You can do it the other way, Jeff. That's true, Jeff. 1.6. Nobody's going to help you, Jeff. All right.
Is it 1.5151 or 52?
Maybe. 1.52? Is that what you guys got? Oh, I gotta
No.
Yeah.
Yeah.
give my brain a rest. Let's see. Dudular. All right. Did everybody get 1.52? You guys good out there? All right. So when we look that up, what do we get here? What's this area?
.9357.
Yeah, 9357. So the answer is going to be 1 minus that. Jeff. Right? So do you see how, I really want you to get this. It took me for freaking ever. I tortured you guys. I put you through the ringer. We talked about Florida, and you're like, I don't even want to. And then what is the only difference between the work for 1A, which is chapter 6, and the work for 1B? What's the only difference?
The standard deviation?
Yeah, the standard deviation changes. Every other single step of work is the same. Do you guys see that? Got a z-score, got a z-score. Looked it up, did 1 minus, or going to do 1 minus. What do you got? I get 0.0643. Did somebody already say that? Can't remember. No. I want, okay. A group of 22. So one woman, could one woman have like X man levels of bone density? Sure. Are you with me? If one woman had like crazy high bone density, we would be like, wow, that's neat. If 22 women that we randomly selected had a bone density, like a crazy high bone density, wouldn't that be pretty freaky? What does pretty freaky mean in probability terms? A higher or lower probability? If something is pretty freaky, that means the probability it would happen is pretty
Low.
low, of course, right? And sure enough, what was the answer up here for one woman? 37.5% chance. Not unusual. I'm like, who cares? This is still not unusual, but it's way lower, right? Now it's only a 6.5% chance that a group of 22 women are going to have a bone density average that high. I really want this to make sense. No, maybe, no. It's that simple. It's
It's going to be lower because there's more women.
no, stop. It has nothing to do with it. It's all about probabilities. So if you went out, I think I said this yesterday, but if you went out and you picked one person and they were over 6'5", that would be kind of like, whoa, right? Are you with me? If you went out, randomly selected 22 people and their average height was over 6'5", wouldn't you stop and look around and go, where the hell am I? What is happening today? What? No, yes, maybe. I
Yeah,
love it.
basketball team.
Yeah, you'd be like, I must have wandered somewhere strange. I mean,
Or Norway.
or yeah, exactly. One of those other countries that have better healthcare. Yeah. So they have a average height. Yes. Okay. Well, which other countries have better? Oh yeah, like all of them. That's right. Sorry, I won't. Sorry. Let's not go there. Okay. So you guys try number 2 real quick. Try to do 2A and 2B. What time is it? Yeah, okay. Want to leave a good amount of time for the midterm stuff. You guys okay out there? All right, tell me this. What is it with part A? Why do I say that it's normally distributed anywhere?
No.
No.
So what is it about part A? Why would I be okay to do this? Because aren't I supposed to know it's a normal curve before I can use the z-score chart to find probabilities, right? How do I know it's normal is basically what I'm asking.
It's more than 30, right?
Yeah, there you go. N is 37, which is greater than 30. Okay, I like it. Now let's see. We'll do this first. Let me make sure you guys are doing correctly here. What's the very first thing you should do in part B?
Draw.
Sure, you can draw. So
Find the
what's
standard deviation.
you got to change this, right? How do I know? because we took a sample and we're talking about the sample mean. Yes?
Is there a certain amount of decimal places you want us to round to for this, or is it just two or just one?
For what now?
For like square root of 37, do you want us to round?
Don't do that. Don't do the square root of 37. Put this whole thing in your calculator at once. And then, like I said earlier this semester, what standard deviation got to go out to?
Three.
At least 3 places. So you can go further if you want to. So this one's a little bit, did I do this on purpose? I can't remember. Did somebody get that new standard deviation figured out? Anybody do this part yet?
Yeah.
I got 2.44.
I got 2.45 with rounding, but
Yes.
Oh,
So I'm going to write too many things, right? So I did this, right?
yeah.
Right. Which would be fine. You could actually use what I just wrote. But if you want to round it, then should this stay at 49 or should it go to 50? It should go to 50, right? Everybody always
Yeah,
freaks
that's
out.
what I did.
Yeah. So when there's a 9 there, people freak out. So it should be 2.450, or you can keep it as 2.4495. Because I said at least 3 places, so you can go 4 places if you want to. Are you guys okay out there? By the way, let's see, the midterm tomorrow will require everybody's camera to be on. So I said that a couple times by now. So if you do have any issues, you should have let me know before now, but obviously let me know now. And I'm also going to want, I don't know, how many guys, does everybody use their laptop camera as your, yeah? I finally, I use my phone as my webcam. I got an Android and this is cool app, Droid Cam, that lets me use it as a webcam. Because here's what I look like using my potato quality. Hello. Sorry. And then my smart, yeah, there we go. Android's got a little bit better camera than my poor little laptop. But it also gives me the chance, if I was in my class, for example, I could angle my camera to show my work area. So I'm not going to just want to see your face tomorrow, unfortunately. I'm going to want to see kind of like your work area to make sure there's not too much typing on the old keyboard, for one thing, for example.
So the only difference is that camera's on, but the test you're gonna post on like Canvas, and then we just fill it out over on paper like we do with all the quizzes.
Yeah, so the way you're going to take it and the way you're going to turn it in is the same, but everything is done during class on camera. So it's not going to be due like the next day or something. It's going to be, we're going to do it tomorrow. And we're going to get done with it before class is over tomorrow.
Would you want my camera like this?
Yeah, there you go. Look at Billy. Everybody,
Yeah,
look at
that's
Billy. That's perfect. I love it.
Then you can't see my keyboard though. I
That's
don't
fine.
know how to
I
hook
could
up
see
my
if
phone
you're-
with my camera.
I could see if you're typing, and then I can go, "Hey, Billy, what the shit?" Right? I will call people out if I see some weirdness happening. All right. What does that mean? I don't trust you guys?
But I'm looking up at a monitor above me, so I'm not cheating.
No, you're fine. That's perfect. Yeah, that's perfect. All right. I'm sorry. Just had to say that while I was thinking about it, or else I'm going to forget. Can we listen to music? Oh, see, that's the funny thing. You're going to be. Here's the funny thing. Just to give you guys ideas. I don't want you to be unmuted, so I have no idea what sound is happening. But if I see you turning like this every now and again, so I'm gonna have to call that shit out. Use my phone for Zoom. You could, yeah, totally. You don't have to. I was just giving that as an option because if you're using a laptop, it's going to be a little hard for you to angle things correctly. You could actually try to use your phone as your webcam. Or you're just going to have to angle your laptop so you can still see it and I can see what I need. Okay. All right. Now, coming back to this. What do I put up here now?
Would it be
75
30
minus
35.
Good, yeah. Good, so my data point that I'm interested in, minus the mean, divided by what?
2.450.
Good. Oh no, a lot of chats happening. How do you use your phone? Yeah, if you have an Android phone, yeah. If you have an Android phone, I use an app called Droid Cam. It's really good. That's what I use. If you have an iPhone, I don't know what the hell to tell you. Those are weird. Do what you need to. Somebody's asked me what time the midterm is tomorrow. Class time. Oh yeah, exactly, Billy. Sorry. All right. So good luck to you. iPhone's got more shit in their app, so I'm sure they got something similar. What do you guys? Anybody get that Z-score? Can you join from phone? Oh, you mean Zoom? Yeah, you can Zoom using your phone. Yeah, that's fine. Because then you'll be able to. Then that's a really good point, Basak. You don't have to use an app. You could just join Zoom on your phone, and then put it somewhere, and then that would be your camera. I like it. Generally, you don't get picture. Oh yeah, that's the other problem. Pretty sure you can. Anyway, if you get
Not
whatever.
if it's like a dial in, because sometimes you can just dial in to Zoom.
But like somebody's pointing out, I need to be able to see you, in your area.
I've been able to use the video on my phone, on
There you
iPhone.
go.
So
I like it.
Same here.
I have
the
not.
quality, I'm not sure though.
I have not connected to Zoom sessions much, and the times that I have connected on my phone, it sucked so bad. But you do what you got to do. Okay. Coming back to this, who's got the Z-score?
Negative 2.122.
Neato. Is that getting everybody else? Yeah. Okay. So if we look up negative 2.12, 2.1. You got to be careful. This is what people do. 2.112. That's not right because that's 0, right? So 2.1012 right there. 0.017. And the beautiful thing about that is I'm done. So the answer is 0.017 or 1.7%. So 1.7% chance that somebody born in 2004 will die sometime before they're 75 years old.
That's low. I would think more people would die before 75.
Well, 2004, California, 80.2 years was the average life expectancy. It actually went down during the recession, Is anybody old enough to remember the recession? The Great Recession.
Yes, I am.
And some of you guys might have been like 7 when that was happening, whatever. And then of course, life expectancy, who knows with the pandemic? I don't know where life expectancy is now, but it's probably nowhere near 80.2 anymore.
Oh, and the opioid epidemic is taking the life expectancy down.
All kinds of stuff. I don't like it. Okay. And again, also, this is not 1 infant. This is 37 infants. So what's the probability that 37 people born in 2004 die before they hit 75? It's going to be kind of low since the average is 80. So, I mean, all that together does make it make sense. All right. I don't think we have to do this, do we? Isn't this the same? What would I do for this problem? I think you guys get the point here. I'm going to have to use my new standard deviation. I would make 2 z-scores, look up the areas, subtract them. Is that cool? Isn't this kind of cool? So chapter 7, you were really worried when I was talking about Florida and all this shit. And I try to tell you, concept's weird, but the thing you have to do is, so it's very minimal. You just change the standard deviation. All the work we did otherwise is the same. It's too nice. Let's do part D though. Part D gets weird. And then we'll devote the rest of the time to review for the midterm. So the middle 95% does this make sense how I'm drawing this? The middle 95%? And I want the sample mean ages. So I know that the mean is still, where'd it go? 80.2, and the standard deviation I'm using is the sample mean one, which is 2.450. How the hell do I do this?
Do you look for the area of 0.95 on the chart?
Now I appreciate, the first thing I do is I'll try to look up some z-scores, right? Because I want to know what this age is and what this age is, but I have to know what their z-scores are first before I can transfer them back into an age. But the area of 0.95 is not an area the chart has a clue what to do with. Is the chart built to understand area between?
No,
It's only built to understand area
below.
below. So for example, this z-score, what area is below it?
2.5?
Yeah, right? Is everybody else cool with that? Don't you remember doing this? 95% in, 5% out, 2.5% on one side. So this is 0.025. Can you guys figure out what the z-score is for that?
Yeah.
Don't say anything. Look it up. Try to figure out what that z-score is. Got an area of 0.025. What z-score would that be? Okay, do this. No. It's all about me. All right, so let's look at this. Am I going to be looking at the positive z-score chart or the negative z-score chart? Which one am I looking at?
Negative?
Negative, good. I can see visually, I can see this is below the mean. So I'm trying to find as close as I can to 0.025, right? In fact, you're going to find it exactly. You guys see it?
0.96.
Mhm.
Yeah. 1.9.
Negative 1.96.
Yeah, negative 1.96. I love it. Now, is everybody okay with that, what just happened? Know the area that's below it, which means I can look out and find out what that z-score must be. I'm just doing the opposite of what we normally do because I know the opposite of what I normally do. So that's, now can somebody tell me without doing any work what this z-score is over on this side?
Positive of the one that was negative.
Yeah, positive 1.96 because it's the middle 95%, so it's symmetric on either side. Because right in the middle, of course, is 0. No. Let me bring this back real quick. So this problem up here I gave you 75. You made it into a z-score, and then you looked up a percentage, an area, correct? Are you guys right? This problem, I gave you an area. We have just looked up the z-scores for that area, and now I want to convert that back to x. Do I have a formula that's solved for x?
Mhm.
Yes. What is it?
X equals z score times standard deviation plus the mean.
Good. So the mean plus z times sigma, and it's going to be the new sigma, right? Because we're talking about sample means. Is that cool? So now I just got to throw stuff in. So for example, this one, it's going to be, what was it? 80.2 minus 1.96 times 2.450, right? I put these up here for us earlier. And then of course, this one is going to look almost the same, except it's going to have a plus because it's positive. Oh, geez. Smush it in there. Okay, there we go. So if you know the area in a normal curve, you can look on the z-score chart to see what z-score goes with that area. Most of mathematics, you're able to go both ways. So if I'm able to look a z-score up to get an area, I should probably be able to look an area up to get a z-score. I just got to work both ways. And then, I don't know, whatever the hell that is. What do you get, Jeff? I don't know.
How did you find the z-score of 1.96 again?
Oh, are you cool with 0.025?
No.
So if there's 95% in here, how much is outside? If there's 95% in here, what percentage is out?
5.
5%.
0.05?
Yeah. So what
Okay.
percentage is on this side? 0.025, right? Cut it in half. So isn't
Okay, I get it.
that's the area below the z-score, and that's why we're able to look it up, because the chart understands areas below. And then I almost don't care what the answer is, but it's like 75 point something, maybe
75.4.
5.4. And so this one will be 85. Is that right?
Yeah.
Woohoo! Jeff can do math.
Wait, I'm sorry. Why did we go from 75.4 to 85?
I don't know. Well, just doing the formula
Just
here.
rounding? Oh.
I don't know. You can double check me if I'm right here, but 80.2 minus this is 75.4. So check that. Just throw in the old calculator. And then 82.2 plus this.
Okay, plus and minus.
Yep. So I will be bringing this problem up again when we get to chapter 8. And that's the reason I put it here as a little precursor to chapter 8. But let's not talk about that anymore because we're not worried about chapter 8 yet. All right, so this is not the last we're going to do with this, but that's the last I'm going to talk about it today because I want the rest of the time today to be devoted to midterm review. So everybody got this stuff here? You still copying this stuff down? And again, if somebody reminds me, I can post this. I think I have other stuff I was supposed to post, but I hope to remember. I'm going to stop sharing and see what happens. Okay. So now it's anything. We could talk about the practice midterm. We could talk about any homework problem that you're still having trouble with from chapter 1 up to 5, right? If you have a 6 or 7 homework problem still, you're going to have to hold on to that until the end. But I want to focus on chapter 1 through 5. What is still troubling you? Which problems do you just wish you could take a hold of and shake and smack it in the face?
Can you give us a sample of a small sample histogram problem? Because I seem to be misunderstanding a simple concept consistently.
Yeah, let's see.
I'm wondering if that's throughout the class or is that just me?
We could probably deal with a review. Don't I have one on the practice midterm?
I haven't taken it yet. That's the next part of my day.
And again, you don't have to do this. This is just up here, but I think, yeah, we do. Okay, so this is not too evil of a problem. So the practice midterm is, it's in its own little area here. So let me become a student so it looks the same for you. Bam. So it's the very first module, practice midterm. And then here's the video of solutions. So we could do, I mean, here's the problem where I want you to create, did I make, yeah, relative frequency histogram. Right, so you guys wanna do that real quick? Yeah, okay. So let's do this. I mean, let's go ahead and do part A and part B. And part C. Why not just do the first three parts? What's a really smart way to make this easier? What can I do with my data first?
Plug it into a list in the calculator.
So that I can
Order it.
sort it. Yeah, that'll make those easy, right? So let's see if we remember how to do that. I need to turn off my office. Let me see. There it is. All right, so
Great, my printer's out of black ink. Super.
you don't have to print this out. It's just all it's doing right now is giving us data to work with. So I still haven't splurged for my calculator emulator, so I still have to do it this way. So, you guys got the data at least?
Almost.
Are you able to, let me do this and see if anybody yells at me. Okay. All right, so I've got the, hold on, I know. I've got the data in here, pop. Got the data in there. And now I'm gonna hit, what do I hit to make it sort? What do I push? What button do I push to make it sort?
Math.
That.
Nope. Stat?
Sorting.
Become a stat, there it is. Stat. Oh crap. All right.
2.
Thank you. Sort ascending. And then I have to tell it which list. So I'm gonna tell it second 1 for list 1. And then it's very anticlimactic. It's like, I did it. So then you go back in, stat, edit, and then it's all in order. Let's make sure, did I plug it in wrong? I probably did. Dadgummit. Knowing me. Are there 2 3s? Yes, thank God. I thought I, is this what you guys get? Oops, you can't see it anymore. Are you with me out there? Okay, I'm gonna go with yes.
Yeah.
We're all failing our vision tests right now. Hold on. Okay. So now, to make a stem and leaf, real quick. Now this is a little bit of weird stem and leaf. Why is this a little bit weird for a stem and leaf? What's the first
So there's only-
There's the 3s.
Yeah, there's no like number in front of it. So what number is in front of it if there's no number in front of it?
0.
0.
Good. So 0, 1, 2. I can't remember now. How far up does it go? That's it. All right. So then this will be the ones 3, Jeff. 3, 3, 4. Can you guys see that all right? Yeah, I guess so. My lighting is weird. Oh, well.
0, 1, 2, 5. Six,
Yeah. So then we get, yeah,
Yes.
0, 1, 2, 3. Who's that?
7, 8, 2, 1, 2, 3, 2, 5.
Good. And is this, if you turn this in, is this good?
No, you need a key.
Good. I need a key. I would pick like one in the middle or something. It actually doesn't matter. You can pick the first one if you want to. Now, the next thing says to create a relative frequency distribution. What's the first thing I need to figure out before I can create that?
As with
What's that?
How many values?
All right, how many classes we want to use, maybe, or do you? I don't know if you meant that. I'm gonna pretend like you did.
Yeah,
That's exactly what I meant.
totally.
So, because what the very first thing I need to calculate is the class width. Do you guys remember that?
Mm-hmm.
Because I mean, this whole thing is gonna be driven by classes, so I can count how many data points fall into them, and I can't make my classes until I know how wide they are. All right. So, what's the hell is the class width formula?
High minus low.
Here's the thing, Jeff. Yeah. So, class width. It's not just high minus low.
divide by
Divide by.
this.
It's the range. Yeah. Good. So the width is the range divided by the number of classes. How many classes do you want to use?
5.
5. Okay. And the range will be the highest minus the lowest. So 25 minus 3. What do I do with that?
Round it up.
You're in a bad spot, but that's too bad. So if I do this, can somebody tell me if I've done anything wrong so far?
Yeah.
What did I do wrong?
It's supposed to be 7. You're supposed to put the 8 down there.
Or should the 8? Yeah, the 8 should be here. Good. So I should be able to see the width 3, and the next one better start at 8 if they're supposed to be 5 apart, which means this has got to be 7, so there's no repeats of stuff. So now just keep adding 5 down. 12, 17, 13, 18, 22. Are we there yet? No. Are we there yet? No. Now we are. Right. And now I can use.
How would we draw the histogram?
Oh, I can't draw the histogram until I get this, because this tells me how tall the bars are going to be on my histogram. So I can't do that yet. So what? Now I've got to get my frequency and my relative frequency. I'm going to erase this in a minute, but I need it for now. So what number goes here?
3.
Good. There's 3 things from 0. I'm sorry, from 3 to 7. There's 3 data points. Now from 8 to 12.
3.
3 again, right? 10, 11, 12. 13 to 17.
3.
4.
Oh, 4.
1, 2, 3, 4. And 18 to 22 looks to be 1, 2. 23 to 27 looks to be 1, 2. small set of data is going to make for kind of a boring histogram, but oh well. Let's check something real quick. 2, 4, 8, 14. Were there 14 data points?
Yeah.
Right? You want to check real quick, make sure you didn't lose anybody or create people. I'm going to erase this. Where I got this. How do I do relative frequency?
You do frequency, or I guess the number of frequency divided by the total number.
The frequency divided by the total. There's 3 out of 14 data points in here, right? Which you can make into a percentage. Is that like 0.21 something?
Yeah, 0.2143.
So let's see, this will be also 2, 4, and then 4 out of 14 will be, don't tell me, 0.29 something, or 286.
0.286.
286, okay. And then 2 out of 14 will be 0.143.
3.
I have memorized my. Anyway, it's just who gives a shit what you've done. All right, and then I can double check and see if these add up to close to 1. If they don't add up to exactly 1, is that terrible?
No.
Why not?
Because we've already rounded.
Because of rounding, but these look like they add up to 1.
Yeah, they do.
Okay, which is just a bonus. It's just, oh, that's cool. Most of the time, these won't. If I'm rounding, they'll probably be a little less or a little. Okay.
But it can be over 1 and you're still not wrong.
Exactly. But so 1.003 is fine. But if you get 1.07, do you understand that's 7% more than it should be? That's when you have created people or something. So that's not good. Don't do that, kids. No clothing. All right. Now I can make my histogram. So the way I've chosen to do this, what do I have to put here? What do I have to put here? Because of how I chose to do this.
2.5 to 7.5.
Yeah, put 2.5, and then I just keep going up by 5, because that's the width. And I think I didn't give myself enough room. Damn you, Jeff.
You can't put 3, 8, 13, 18?
I can't. Did you do this too?
Yeah, I did it like that.
Either one of us can do that.
Okay.
You can only do what you want, what you're saying, if you had done this.
Oh, so you have to have decimals in it. Okay, got it.
So if you do this way, you can use 3, 8, whatever. But if you do it this way, no. Why? Because that's the way this way works. 27.5. Oh, you just gotta trust me, that's what that is. Now, do I use the frequency numbers or do I use the percentages?
Percentages?
Yes, because it asked me to create a relative frequency histogram, right? Okay. Well, last thing it's wrong. Okay, that's freaking me out. Let's see. So what kind of scale do I want? I have to be able to make it up to almost 30%, right? So maybe let's go by 5s. And it doesn't really, Jeff, try harder. Don't let them know you can't work with numbers. All right. So how tall is the first bar?
21.4.
21.4. So just a little bit over 20. We're doing it by hand, so we can't be perfect. And then 20, so it's going to go straight across. And then I got the big old one in the middle. It's like it's flipping us off. Oh, man, this is where I started. My scale gets weird. And then I got 14 across for the next 2. Is that cool? So about right underneath 15. I got there. Let me put you over here. There. Put you over here. There. what anything still missing that I would take
Labels.
points off?
The labels on the bottom.
Yes. So what do I put here?
I forgot what the question was.
Me too. That's why I asked, and I was trying to hide it. Somebody have it there?
Temperatures taken.
Oh, in Townsville? No. Is this the Townsville problem?
Alaska.
Temperatures taken in Alaska.
Oh, Alaska. I had a different problem somewhere else. The town of Townsville. Temperatures, temps at station in Alaska. I forgot the postal code for Alaska. Is it AK? Alabama's AL. Anyway, different. Is that okay?
Would you put relative frequencies on the side?
Yeah.
Okay.
Put a little tiny RF there because I didn't have much room. So if I put an RF, obviously I'm going to be cool with it because that's what I just did.
Relative freak. FREQ.
So the real freak. Exactly. These are freaks. These are real freaks. All right.
Wait, where did you just get the numbers 20 and 30 from? What step did I miss?
These numbers?
Mm-hmm.
So I know I'm going to have to use
Actual data points.
Sorry?
I'm sorry. Please continue.
Oh, so I know I'm going to have to make a relative frequency histogram. So I know the heights are going to be related to these percentages. The tallest one is almost 30%. So I had to choose a scale here to get me up to 30.
Because it's in percentages, not probabilities. Got you.
Yeah, and later we actually learned that percentages are probabilities. What's the probability that we pick a data point between 13 and 17?
0.286.
Yes, exactly. Cool. I like it. I like it. Any questions on how that works? What could have been different for somebody else in this problem? There's one thing that actually changes a lot, but there's one thing that we chose that somebody else could have chosen differently.
Number of classes?
Yes, somebody could have chosen like 6, right? Don't choose 7 or 8 or 9 or 10 because, all right, was this a really big sample?
No.
So, I mean, 6 would be okay. So somebody could have chosen 6. That would have changed your width. That would have changed all these. That would have changed all these. That would have changed all these. Holy shit. All right. Where to next?
So always go down a fifth to start a column.
Down.
0.5 to start a column.
Oh, yeah. Remember, these are the limits and these are the boundaries. But if we would have used this kind of classes, I could have put 3, 8, 13. I could have, yeah. So if you want to do this way, you can have nice, clean. If you want to do this way, you got to have the limits. Now, to be really honest, there is a way that I didn't really talk about. Can anybody tell me what the number is in the middle of 3 and 7? What's right in the middle of 3 and 7?
5.
5. So you
5
actually could have done this like this. You could use midpoints. So let me see if you guys are cool with this.
Don't add another thing.
Kind of gross.
5, 10, 15. It's up to you. It's up to you.
Oh, can we ever use a number of classes that's less than 5? Because sometimes the numbers are so small.
For us, no. I mean, I really hope you guys realize that there are certain things we do in this class that are kind of, in the real world, it would depend on what your purpose was or what kind of data you're working with or anything. So in the real world, is there a 5 to 10 rule for classes? No, there isn't. But for the size samples we're dealing with and the reason we're creating these things, 5 to 10 makes sense, right? So there are, and then like my rounding of standard deviation to 3 places, that's really just to make sure that we don't round too much. In the real world, How much you round depends on what you're doing again, right? But it's just, yeah, but
What if you have a data set that's like 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 4, 4, 4, 4, like the space between the numbers isn't enough to meet a,
so that's another
then
thing.
what?
We keep rounding, like we did 4.4 rounded up to 5. Yours, you're almost going to have to use a decimal with. Yeah, I don't know. But I mean, there's certain data structure, there's certain data sets that it wouldn't even make sense to make a histogram for sure, right? That one would be less of a histogram and more like a bar graph. That's still, so you'd have a bar for ones, a bar for twos, a bar for threes. So it wouldn't really be classes, right?
Right, so this is only for more bigger data sets.
Larger data sets with more variation. Yes. Okay. So if you want to look at the midterm and pick out some other kind of problem to focus on, do you have a question from homework? If nobody's asking anything, that means that it's your floor. Oh, somebody's got a, I'm sorry. I still have trouble identifying formulas for ZS. All right, I don't understand. But there's only 2 formulas for the Z-score we've done so far, right? X minus the mean divided by the standard deviation. And then like the one we did today is the same thing really. It's X bar minus the mean divided by the new standard deviation, right? But it's the same formula. So I don't know what you mean though. I am gonna give you the formula for like standard deviation, sigma and S. Are you guys with me? I am gonna give you those formulas. So you're gonna have to help me out a little bit. You're also asking about dependent, independent, and mutually exclusive. And this is gonna be something that just haunts me for my whole life, but how do you show that 2 things are independent? What would you have to show? So
They have nothing to do with each other.
No.
That probability,
Sorry.
go ahead.
That the occurrence of one doesn't affect the occurrence of the other.
Good. Now, use less English. Use more math.
Probability of A given B is equal to probability of A.
Yes. If this and this, then B and A independent, and vice versa. So when I ask you, oh, here we go. Trina's got it in there. Exactly. So that's basically what I just put up here. I don't worry about the last guy because if these 2 are true, then the last guy's true. So and really normally I only have to show one of these is true. But then we had that weird problem where there was nothing but zeros in a column and that made it all freaky. And then anyways. If I ask you, are these 2 things independent? And again, if you start saying, well, no, because you can be, no, you're wrong already. You are wrong. You are already wrong. This is fundamentally a mathematical question. You have to do this, and you have to do this, and you have to show that they are the same, or if they're different, then it's dependent. Is everybody with me? I think most people did it right on the quiz. And I almost always, I make you figure out what this is, and I make you figure out what this is somewhere else, and then you just have to identify, oh, I did the work already. I just got to say that they're not equal to each other. Is that all right? Okay. So let me see, what else did I miss? Did I cut somebody off a minute ago?
I have a question that's kind of related to that, the probability of A given B.
Yeah.
So what I keep messing up, and it seems like fairly simple, but every time I do like probability of A given B, and then like, the formula is the probability of A and B over the probability of B, somehow I always just end up getting the same thing as the probability of A.
Because I know exactly why.
Okay.
Wait, and you're not alone with this. Way too many of you guys keyed in on me saying and means multiply.
Okay.
And you forget that it's and means basically multiply. It's not always just straight up. So what a lot of you guys are doing is you're doing this. I have made a gigantic assumption here. I have assumed to go from here to here, I have assumed independence. If I don't know that they're independent, I can't do that. So the problem had to tell me this, or it had to give me a way to figure it out. If I don't know if they're independent, I cannot do this. So that is, I guarantee you, that's what's happening.
So then if you don't know if they're independent, would you just,
If they're dependent, what's the formula?
right.
No, stop. All right, hold on. What is the formula period for and is the better question. Not dependent, it doesn't matter.
And always means times.
That's not good enough. What's the formula?
Doesn't it depend? Because
Nope, it sure don't. It does not. You gotta.
A, B amount of times.
No.
Probability of A given B.
Oh, all right, well. So the probability of A times probability of B given A. Jeff, am I just hungry and I want a PB and J? Is that what it is? All right, hold on. Probability of A times probability of B given A, or the probability of B times Jeff. What's happening with you, buddy? I'm tired.
Yeah.
but there are times in the textbook that I've seen probability of A and B is equal to probability A times probability B.
Was that sitting by itself, or did they have like a setup before that, saying something like A and B are independent? Then
Maybe.
if A and B are independent, what does that mean?
That probability A.
Probability of A given B is the probability of A.
So then how could I rewrite this in this situation?
P A line B.
No, come on. What we just say? If they are independent, this equals this. So what could I put here?
P probability A.
There we go. That's the only, see, that's what I meant when I said that earlier. If you are replacing and, like B and A, and you're replacing with the probability of B times the probability of A, you are assuming they're independent because it's the only time that's true. And the funny thing is, I think I tried to make this connection before, but this is an easy connection to miss. Let me see. I think there's a problem on this midterm like this. Let me see. Hold on. There might not be. Oh, so real quick, just so you don't get too excited, there will be probability questions on the midterm. Okay. I don't think I put any problems on here because we had just done the quiz. All right, so let me make another problem real quick. Hold on. Let's see. So yeah, so it's just like that haunted house problem, or what's a good problem I can make real quick? All right, so if I have 4 Twix bars and 3 Butterfinger bars, right? And I pick 2 bars, what's the probability I get a Twix and then a Butterfinger? Well, there's something I haven't told you yet.
Wait, what's the difference between probability of A and B versus probability of B times probability of A? Isn't it the same exact thing?
No, because what is the probability of A and B? What's the formula? Isn't this the formula? That's the formula.
So probability of A and B equaling probability of A times B is only that in the case where it's been established that they're both already independent. But if you don't know that,
If you don't know that,
then
then
it's
the probability of A and
probability
B
of A is equal
is one of these.
given A. Yeah, okay.
Same thing if you don't know that they're mutually exclusive. You can't just say probability of A plus probability of B. You got to subtract the probability of A and B, right? But if I know they're mutually exclusive, I can forget that part. Now,
So what you just circled is independent. I'm sorry, just for clarity.
no, so, all right,
Fuck.
I love you guys so much. So, no matter what, no, this is why I wanted to make this exactly like this. Don't ask me, what about this? What? No, no. No matter what, this is the formula for probability of A and B, right? You hear me? No matter what, this is the formula for it. Probability of A times probability of B given A, or probability of B times probability of A given B. If they're independent, then this piece becomes easier. That's all. Do you guys understand what I just said?
So you
Yes.
just like
Go ahead.
plug that in where the probability of A and B is in the formula for the probability of A given B.
All right, so this is why it depends on the problem. Jessica, you got to really understand. Depending on what the problem gives me, it will alter how I do it. So I can't answer the question you're asking without knowing what you know, what you were given. Does that make sense?
Well,
What kind of
okay.
information? Yeah. Are you looking at a specific problem?
No.
Okay.
Well, I guess if you wanted to, it
Fine.
would be. Sorry, I mean, I don't want to like take
No.
up a whole bunch of time, but
Everybody wants this. Trust me. So what do you got?
so it was, I think, like the very last two on the quiz was where I did that, and I shouldn't have. And then so I guess what I was wondering is, you're saying you can't just multiply them if you don't know whether or not they're independent.
Right.
So if you don't know, I guess what I'm trying to ask is, because this particular thing was happening when I was using the formula for A given B.
Go ahead. Yeah.
And then the and is in that formula. So then would I just sub out where it says the probability of A and B with what you've written up there?
All right, now watch.
So like you're just making a substitution in the formula since you don't know whether or not they're independent? Is that what you are saying?
Let me try to show you, I think. All right, do you see this problem? So this is an example problem. This is a lot like what I gave you on the quiz. Can somebody tell me from here's what I gave you. Do you know how to figure out what this is?
Multiply it.
Yeah. So I would do probability of L times probability of W given M. Is that cool? Because I mean, A and B doesn't matter what letters they are, really, right? Formula holds. So I'm just going to multiply the two numbers that I gave you. Did I put it in the right place now? Let's put it in the right place.
I have a question about the probability given, like when you say W given L, wouldn't it always just be like W when you just multiply that by, or what situations where it would not be, because when you take the W and then multiply it by L and then divide by L, it just leaves you with W.
This is what I was saying. Okay, so all right, so like this, the formula for it is this, right? So let me say this one more time. You cannot replace the top with this unless you know what. You cannot.
That they're independent.
They have to be independent to be able to do this, because look what this leads to. If I do this, I'm assuming they're independent. And then what do I have? Probability of W given L equals probability of W. Doesn't that mean independent?
Mm-hmm.
Does that mean they're independent? No, because I might have made a mistake. I assumed they were independent. So of course math is going to go, Oh, I think then they must be independent. Human person, right? Math doesn't know shit. So if I plug something in that assumes they're independent, it's going to look like they're independent. Now, just go with me. Give me a minute. Let me work on this. Is everybody with me down here? Right? Okay. Let me make myself some room up here. So what if I then, so this is part A. Now, what if on part B, I say the probability of W, well, let's see. Well, this is going to be too much. Now, screw it. I'm not going to do exactly your quiz. Yeah, you guys got to do some corrections. What if I just tell you the probability of W is, what do you got, Jeff? You can do it, buddy. Can you do it? Sure, look, all right. Now, so it's the same problem. You with me? I know I put it, so this is all the same problem. Everybody with me? So we know all this shit, we know this, and now I know this, correct? Can you figure out what this is? Is it just 0.7?
Mm-mm.
No, it's the other way around, right?
Would it be probability of W and L
All right.
divided by probability W?
Do we know the probability of W and L?
Mm-hmm.
Yeah, we figured it out. So this, I don't know, Jessica and whoever else has asked me, if I'm given this kind of information, that's how I figure out what the and is. And then I can figure out the given the other way around because I know what the and is. So now I'm going to put in there 0.14. Is that cool? That's what the and is. 0.14 divided by the probability of W, which is 0.3.
I totally see now. I just overlooked the fact that you did the given, and which is what I did with like the part A, like the last ones. There's like A, B, and C or whatever.
Yes.
I almost did that on A too, and I was like, well, wait, he gave me the given, and then so it's like I figured it out on the first one, and the second one I didn't figure it out, and I
know. And again, I hope you guys understand that just because I take points off and all, it doesn't mean that I expect you to be perfect, right? I mean, that's never what that means. It's just an accurate representation of what you know, and then I'll let you make corrections so you can kind of close some loops on what you didn't know. There's one more thing I wanted to say here. Oh yeah, on the quiz, there was that question where it said probability of B. I think most everybody got it fine. I'm gonna erase all this. You ready for that? I almost don't care what the answer is here, but you just divide those and you get it. Actually, I'm sort of curious. What do you get here? You get 103, so like 0.47. Nobody's gonna help me. We'll see. Yeah, 0.47. So look at me go. I'll be even more specific. There we go. Now, real quick, watch, real quick. What's the probability of L in this problem?
0.2.
0.2.
0.2. If I know W happened, what happens to the probability of L? It increases quite a bit, right? It more than doubles, doesn't it? It goes from 20% to almost 50%, right? I like it. No, yes?
Mm-hmm.
Sort of like, what's a good example? Real quick, Jeff, you could do it. I don't know. That's a dumb example. I can only think of dumb examples. Oh no, I don't know. Shit. Oh, screw it. So it's that dumb, I don't know why I can only think of dumb examples for this, but that's just where my brain is. But the whole thing about the person getting off the Harley Davidson, that's a horrible example. I'm really sorry for that. But let's say you get up late. Okay, ignore that. What's the probability you're going to have a bad day? 50-50. Let's say that you get up late, later than you needed to. Does that affect the probability you're going to have a bad day?
Yes.
Yes. Right? Or it's probably going to have a bad day, 50-50. So you go to the kitchen and you realize you're out of coffee. Does that affect the probability you're going to have a bad day? Yeah. For some of us, it affects us very much. Some of you guys are like, I don't drink coffee. I was like, that must be nice. I'm addicted. Oh God. All right. Anyway, all right. Enough of this. What do you want to do next? What do you want to look at next? It's totally up to you guys.
Can we go over nominal, ordinal, interval, ratio? Because I always end up confusing them.
Yeah, so let's look at this here. Which two mean you have something that is truly numerical? Which two would be for truly numerical data? Anybody remember? Which two would be for truly numerical data?
The average temperature?
No, I mean, no. From the 4 types, which two are truly numerical?
Interval and ratio.
Interval ratio, I like it. Interval means that you can do what with data and it makes sense.
Is it division? No, it's
Subtract it.
Subtraction, right? Because interval is from something to something. So you can see how wide it is by subtraction. Ratio is another name for what operation? Now you come in with the
Division.
So if you can divide two data points and it makes sense, that's ratio. If you can subtract 2 data points and it makes sense, that's interval. Everybody with me so far? And you can only subtract and divide stuff if they are truly numerical. What do I mean by that? Is a zip code a number? Yes. Is it truly numerical in the sense that we're talking about? No. Right? Because if I subtract them, the answer doesn't make sense. It doesn't mean anything. No. I love it. I can only see a few of you. And the few of you I can see you have this. I will not react. All right, so nominal and ordinal is if they're really just names. Nominal means it's only names. For some reason, some of you guys think that nominal is number. No, nom, plume de nom. It's a French way to say pen name. It's names. So absolutely the opposite of numbers. So nominal ordinal is if it's not truly numerical. So in part A, don't look at the number, remember? Don't look at this 30%. Say to yourself, what was the question that somebody was asking? What am I walking around talking to my sample? What am I asking them?
How many of them owned Hyundais?
All right, I would accept that. So if the question was, how many of them own Hyundais, what level am I at? What's the answer? Give me some answers to that question. Give me some answers to that question. How many of this group own how many of that group own a Hyundai? You can do it.
Ratio?
No. Okay, sure. That's a big jump from where I am right now. So the way I would look at these problems is I would say, okay, what's the question I would ask to get to this? Okay, so one question you could say you're asking is, how many people own Hyundais? Then you say, okay, give yourself some numbers. 5 people could say that, or 10 people could say that.
Mm-hmm.
When I divide 10 divided by 5, does the answer make physical sense? I get 2. What does that mean physically? If one group said 10 and the other group said 5, what does 2 mean physically?
That there's twice as many people in the other group?
Twice as many people in the one group, yeah. So then it's ratio. Now, did somebody else think a different thing? What else could I have been asking people as I was walking around? I could just ask him what?
The average temperature.
No. Let's still looking at part A. Couldn't I have asked him what kind of car you got? What kind of car you got? What kind of car you got? And then I counted up the Hyundais. Then I saw there was 30% of them. So what would it be if my question was, what kind of car are you driving? What kind of answers could I get to that? What kind of car do you drive? Sorry? You can tell me, what kind of car do you drive?
Honda.
There, Honda. Somebody else?
Volkswagen.
Volkswagen. All right. That's
Honda.
And what are those numbers?
No.
Nope. Are they categories?
Yeah.
Do they have to be in a certain order to make sense? No. So,
No.
yeah, right. If I said, if there was a list and it's like check, you put the check next to your car and it said, do you have a BMW? Do you have a Ford? Do you have a Chevy? Would you go, wait a minute, Chevy should be first because it's does it have to be in a certain order? No, it does not have to be in a certain order to make sense. So part A is totally nominal. It's just names of cars. Now, if you say, on the actual midterm, I'm going to say why. If you say it's ratio because it's the number of Hyundais owned, and 0 would mean none were owned. You guys with me? So that's why the why piece is the most important part.
So you could do either or. You could put
I
nominal.
told you guys before. There could be more than one thing because I wasn't specific enough here as terms of what the question would have been. Now, if you've paid attention, this kind of problem I've done before, I would put 30% had Hyundais, 20% had Ford, 30% had Chevy, 17% had the Volkswagen POS or whatever, right? Not all Volkswagens are POS. We always want it to be nominal. You can categorize the name. No, come on. Ordinal is if they have to be in order.
Okay, yeah, we got it.
Giant cat. All right, sorry. So to me, what I intended with this is just nominal. It's just names of cars, right? Names of cars. But if you look at it as number of Hyundais, then it would be ratio because you could have 0 people with Hyundais. So what about this one here? What do you think I'm talking about here? Do you think this is pretty much going to have to be Fahrenheit, maybe Celsius, but this would be insane for Celsius. So does somebody remember about temperatures? At what level is it at? Does 0? Sorry? Yeah,
Is it interval?
Does 0 degrees mean the absence of all heat?
No.
Nope. So it can't be ratio because 0 does not mean what it's supposed to. What is 0 supposed to mean? The absence of blank. All right. And then part C is the one. What's part C? What kind of answers could I get to the question I ask?
Can you have part of a TV? So that's how you know it's not or it wouldn't be
You're
ratio.
thinking about ratio versus, you're thinking about discrete versus continuous. That's not the question. Right? What question would I ask people to be able to get to this point? To be able
How
to.
many TVs you
How
have?
many TVs do you own? If somebody said 0, what would that mean?
0.
Don't say 0 is 0. You got to tell me.
They have no TVs.
There you go. The absence of TVs. They have no TVs. So 0 means what it's supposed to. So what level is that?
Ratio.
Yeah. Ratio is where 0 means what it's supposed to. Yeah. What about number 5? This is related to the one I told you I was going to ask you every single time. What would a z-score of 1.52 tell you about the data point?
that the data point is 1.52 standard deviation away from the mean.
Beautiful. Kick ass. Lovely. You could also, instead of saying away, say above, because it's positive, but away is perfect. That's perfect. You guys understand that? Can I get everybody get this kind of question correct? Because you know it's coming. You know this kind of question's coming. Can we all just get that right? I have not yet had one where everybody got it right, so we'll see what happens.
I just think that the car question could be ordinal because you could argue that, like, I mean, I have a Honda, but I want an Audi, so I would organize an Audi above a Honda.
That is your own personal ordering. Does it have to be in that order to make sense to everybody? So this is my point. There has to be an inherent order. There has to be an order that the data itself needs to be in. That's an order that you would put it in. Is it order that the data needs to be in? No. That's what inherent means. It means the data wants it, not you want it. So that's
categorical is no order.
Say again?
Categorical is just no order.
And nominal is name data that has no order it needs to be in. Ordinal is name data that needs to be in order, like ranking something, right?
And what's categorical?
That's what we just said. So categorical is name data. Categories, just name data, right? Hair colors are categories. They're just names.
So what's nominal?
Nominal is name data. Nominal is categorical data.
Nominal and categorical are the same thing.
Yes.
Okay.
I'm not sure what you, I'm sorry, Samantha, I missed whatever that was for repeating. I guess I did it. Z-score, yes, okay, got you. Data point, yeah, there it is, that's better, yeah. Okay.
Would letter grades be ordinal? Because even though it's letters, they have to be in order to make sense.
Yes, good, I like it. There's an inherent order they want to be in. Right?
Can we go over number 10, please?
Which one?
Number 10. So I'm stuck at where you would get the standard deviation. So I like got all the lists filled out and stuff, but
what's this list? What would go like here at the top to
there'd
identify?
be x times p of x, or yeah.
And once you multiply all these, you multiply, and then you add them up and you get the what?
The mean.
Good, so now the mean is the sum of x p of x.
Mm-hmm.
What's this column gonna be?
X squared times p of x.
Good, and you multiply, and you add them, and then you add them all up, and that is a part.
That's what you would call like the variance, right? And then you would do the square root and stuff like that from there.
Yeah, I want to make sure you understand. This is just a part of the formula, so that would go here, but then you also have the minus the mean squared. Yeah.
Oh, okay.
Whatever
So
number this is goes here, and then you
Okay.
subtract the mean squared. That's the formula. And again, the formula is going to be on the midterms.
Okay. All right. That's it. Thank you.
You're welcome. By the way, did not everybody? I sent an email about this, I think, right, about the video I put up to help you with chapter 4 homework, but apparently several people ignored that, maybe, I don't know. But I did a whole little video to help you with some of the homework in chapter 4 related to binomial probabilities, right? So that's up there. But let's look at this problem for the practice midterm. Where'd you go? You're way up here. Where'd you go? Yeah, number 11. When you look at number 11, can you see what N, P, and Q are?
N is 24,
Good, because we got 24 people.
and then I think P would be 8.88.
0.88, good, because that's the probability that they think DNA tests are very reliable, and that's what I'm looking for.
And then Q would be 0.12 because everything it's not, or -1.
The rest, I like it. And double check that, because if you make a mistake there, everything's going to be off, right? So make sure that P plus Q is 1. Right? And then for this first problem, it's probably exactly 22, which is different than this problem for sure. So how do I do the probability exactly 22? How do I set that up?
Would you do 22 count?
No, careful. How many people total do I have?
Oh, 24?
24. Choose.
22?
Good. So choose 22 people from 24 people. So then how many successes do I want?
0.88. 22?
Of course. And then how many failures do I want?
Oh, 2?
Yes, because I have to have 24 total people. And you just throw that in the old calculator. Throw the old calculator. Now, how the hell do you do part B? What the shit, Jeff? How do you do part B?
Find the probability for x equal to 23 and 24.
Sort of, maybe. Why? How? What then?
And then take those, do 1 minus that.
So, real quick. What does x less than 22 mean in this problem? I'm not saying you're wrong, by the way. I just want to get everybody caught up with what you just said. What does x less than 22 mean? What could it be?
21, 20, 19.
So you'd have to do the formula for every one of those to calculate this directly. Is that a lot of work?
Mhm.
Oh, by the way, all right, I was about to say something kind of mean, but you guys, have you met me? Do you guys know that I like work to be shown, right? So no, you cannot just use binomial, CDF, and PDF. No. You should know that I need to see this formula, right? If you look at the binomial, CDF, and PDF, you can kind of check your work. That's fantastic. You can have the calculator check your work, but you have to have work in the first place to check. So this thing, do you guys agree with me? This is a lot of freaking work here, right? So what's wrong with me? God, I'm an asshole. But not me. I'm not the asshole. You have to know that if that's a lot of work, what's the opposite of this? What's the opposite of less than 22?
More than 22?
Almost. You left out one thing.
More than or equal to.
There we go. Yeah, you got it. So if I can calculate the probability x is great, now why is that less work? Because what's the only stuff that's greater than or equal to 22 in this problem? 22 or
23
3
and
or
24.
that's it, because that's as many people as I got, right? So that's a lot less work than 21, 20, 19, 18, 17, 16, 15. No, Jesus. I'd rather just do, look, this one we already did, right? Look at Jeff try to be nice if you'll just let him. Right, so I already did this. You just have to do whatever this number is. That's what goes here. And I just have to do the formula for this. You know, this formula, you have to put 23 in instead of 22, and then you have to do it for 24. right? Add them all up and then subtract it from 1. So what you're doing is you're answering the opposite question, and then you're just doing 1 minus that. Now you're answering the actual question. Real quick, by the way, real quick, guys, real quick. When I do a problem like this, and I want to know this area, what do? Don't we look up this area first? Don't we answer the opposite of the question? No? Do you guys remember what I'm talking about? So if I want to know the area up here, don't I look 1.1 up and find the area down here first and then do 1 minus? Don't I? Unless you like the shortcut, but still. No, you don't know. Okay. So I'm just trying to show you that's the same idea. It's just if the opposite probability is easier, I'm going to do that way. Well, no, Billy, because we're going to leave pretty soon. Yeah. I mean, you can take a break anytime you want to be honest. Today's just review. So hopefully not. I got a meeting at 4, so hopefully we're not going all the way to 4. Okay. Is that, you guys okay out there? Do you guys understand what? So we got 22 here. Then we just have to do this exact same formula for 23. This exact same formula for 24. Add them all up, subtract it from 1.
So we have to show 24, C 22, and then sub in the numbers on the test, or can we just sub in the numbers and then do the...
You have to show me work, yes. You have to show me work.
Okay, I'm just not familiar with that formula, so...
Oh. Well, then how are you getting the number? How are you getting the answer?
That just makes sense.
No, wait. So you could just tell me what this is? Does it make sense?
I don't know, man. I'm confused. I'm gonna shut up now.
So here's what I'm trying to say. Let me see where can I do this? Okay, let's do this. Let me go up to the board. Okay. All right, hold on. So it says probability, I already forgot what it was. X less than, there we go, less than 22. And this is equal to 1 minus the probability for any. So if we just focus on this, this is the probability of 22 plus the probability of 23 plus the probability of 24. So that is that formula. We just put, oh, I forgot already what these were, 88.
I was just confused on where the calculate sign came from.
What, the what now? Sorry? This thing?
Yeah.
This is the number of ways to choose 22 from 24. So this is in the calculator, it's math, probability. I think it's number 3, right? And again, as you're studying, you should have sitting next to you the worksheets that we've done so far, because it's got all the information on them, right? So it's so vital to remember where formulas came from. So if I want 22 successes, remember P is success, right? So wouldn't I have 22 P's and 2 Q's, correct? And then it's all about, well, how many ways can I order this? Blah, 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 blah. Big ass list. This tells me how long that list would be. That's all it does. That tells me how long the list would be. And then each one of them is p to the 22nd power, q to the 2nd power. Each one of these. All right, and that's sort of like the 10-second version of that long ass lecture from before. But here I'm just going to add 24, choose 23. You can do it, Jeff. There you go. 8 to the 23.12 to the first power, right? Because now I need 24 total, plus 24, choose 24. Right? So this would be the opposite of what I want. Then I would do 1 minus what I get to get the answer. Okay. Which is what you need to be doing in a couple problems in the homework. And again, I'm going to have all the formulas that I said you didn't have to memorize. So like the mean and standard deviation for this, I'm going to have on the formula sheet. This is something you have to know. Do you remember how far to go to find the min and max values? To find where unusual starts, how far do you go?
3 standard deviations.
Oh, just 2.
2.
Yeah, 3 would be like really unusual. Yeah. Oh, and by the way, I said this earlier, but not everybody was here yet. Do not worry about 12E. That's a rogue problem that snuck on here. It's related to chapter 7. Do not worry about 12E. If you're looking at this practice, Midterm. Okay. Whew. Any other type of problem that you still need to look at, or?
For C and D for number 10 also, I just want to make sure I'm like doing this correctly. It's asking for the probability that X is more than 2. So you would just like take X, so it would be like 4 out of 5, correct?
No.
No?
Give me a data point that's more than 2.
3.
Good. How many? What percentage of the data is 3?
Oh.
So you have to add
So
up.
like add them all up. So like kind of like the cumulative frequency type.
Or
Okay.
you could just do 1 minus this.
Yeah. Okay.
See, chat, could you possibly plug in the problem on the whiteboard into a calculator? I got the math button. I don't know how to plug it in. Oh, okay. I can do one of them. Let's see. Let me stop sharing. All right. So I'm going to do this first one here, right? 24. All right, let me get all blurry. Why are you over there? Okay. All right, let me get blurry here real quick. Okay, and now I'm blurry. So 24, so I got 24 in there. Math, probability, number 3. So my calculator looks like this. Your calculator might say NCR. So 24 choose 22. 24 choose 22. You guys see that okay? I don't know if I'm focused correctly. I really got to fix my calculator. Oh, you guys can't see shit. There we go, maybe. It's a little too bright.
Can we write 24 NCR 22 on the test instead of calculate, just so it makes more sense?
What?
Can we write 24 NCR 22 on the test?
If you want to. Yeah, you could. Yeah.
And that would make my, but just it makes it more sense to me.
So there's 24, choose 22. And then I'm going to the over arrow. And then I'm going to put in there times 0.88. Times 0.88. Damn it. To the. So there's my to the button. To the 20 seconds. In there. Show it to me. There we go. And then we hit the over arrow to come back down. Times 0.12 squared. Enter. So 0.237. So then I'll write that down. And then I would put this formula in. Oh, shit. Oh, man. There we go. Then I'll put this formula in, and I'll put this formula in, then I'd add all those up, and then I would subtract it from 1, because all that work gets the opposite answer. So I got to do 1 minus all that to get the actual answer at once.
Will you be joining us at 10:30 tomorrow morning as well?
I have no idea. Did you guys figure out a way to set up nobody's communicate with me about it at all. So
Yesterday we picked we put in the chat Thursday 10:30 a.m. But I thought that, I mean, I might be wrong, but I thought that you had said since you can put together a larger one that you would set it up if we pick the time.
yes, I can. I told you to let me know if you need that. I didn't know if you guys had some other way to do it. So I can set it up and then I can email it out to everybody. It'll be a Zoom.
Yeah, that'd be good.
Sorry?
Yeah, that'd be great. As far as I know, I don't think we have a way to create a big group because we don't have Zoom accounts through Grossmont.
You guys have taught me some technological stuff, like Discord and Group Me, I think. So yeah, I could set that up and then send it out to everybody. In fact, I don't see why. Well, maybe we should. No, is that too early? Do you guys think you're going to be in there for like 2.5 hours?
No. I imagine, we covered a lot of stuff today. So I think, at least for me, like I'm going to do the midterm practice after class. And then my questions from that, I'll probably bring.
Okay, so I'll make a separate, I was just trying to think about if I want to use the same thing as tomorrow's class, but I'll make a separate Zoom thing for the study group. And I'll send that out. No worries. All right. So maybe if there's another 1 or 2 questions right now. And by the way, the first part of class, we will have some time to ask questions before the midterm officially starts. So it's not going to start like right at 1:30. What's happening? Something happening in this chat here? I got one. Did I do something? Yes, you definitely did. Still having trouble with this. Saying this night reviewing lectures. I don't even know what lecture date. I don't know what that means. All of my videos have descriptions on them. Somebody says, hope not. I don't know what for. Okay. I love you guys. Okay. Oh, sure. I try, man. I really do. I try. I understand. Okay. So I'm going to create this thing. I'll send it out to everybody. Is there anything real quick right now? Any questions right now?
Yeah, I have a question.
Yeah.
Is it too late to take the quiz 3?
Yes.
Okay, because I sent you an email. I don't know if you looked at it, but I had a night shift from 12 to 6. So I couldn't wake up at 10 because I just knocked out.
Wake up at 10. So so I gave 40 something hours within which to find time for the quiz. So, and that's why I do that. Right. So the quiz opened for like 3:30 on Monday. and then I gave you until 11 a.m. today. So the reason I do that is because I know that people have a lot of shit happening. So you just find whatever time you can. And if it's absolutely impossible, you have to email me while it's still active and tell me I am not going to be able to find time, and then we can work something out. So what's going to happen now is instead of a 0, I'm going to use the midterm grade in the place of your missing quiz grade. So it's not going to be a 0.
Okay, so should I just not take it at all?
You could look at it. You could look at it. You could open it. You could try the problems out. You could ask me if you got them right. It's just not going to count.
Oh, okay. All right. Thanks.
Sure.
I have a question about the z-score table. So I have printed out one and show you.
Yeah, you're fine.
Okay, and I was just wondering if that's okay. 'Cause I have like all the tables on it, but I also have like formulas in front that we use in this class. I like write little notes on them.
That's,
like I wrote.
that's not good.
Oh, yeah, so I can't use that.
You can't use notes.
Okay. The tables, would that be okay if I just like use them, or should I use the ones that you provided?
You just have a printout of the tables. That's fine.
Yeah, I have the
Notes on it.
z-score, and then I have the z-score and negatives.
Oh, that's right. You don't. That's right. So Billy's reminding me about that. It doesn't go to chapter 6 anymore anyway. You don't need the z-score tables.
Oh, I don't need them?
No, the midterm is only going up to chapter 5.
Okay.
The
Never mind then.
z-score table we did in chapter 6. Yeah. Thanks, Billy, for reminding me. Okay. Anything else, guys? Yeah.
So I guess I know that you've gone over this a couple of times, but I get a little confused. Probability, you round to the 4th place.
Now, real quick, do you guys understand why I did that? On the
The
z-score chart,
percentages
on the
and on
z-score
the z-score score.
it goes out 4 places. Yeah, okay.
Is there any other ones that you have a specific decimal place like
Standard
specification?
deviation is at least what? Standard deviation is at least 3 places. So like I said at the beginning, if you just take everything to 4 places, you're covered.
Okay. Because some of them you said that we only need to do 2 decimal places. So that's
Why?
why.
What's that?
I think it was frequency stuff.
No.
Like the
Well,
histogram.
I mean, yeah, because if we're doing it by hand,
Okay.
you don't have to get that precise, but you don't.
The z-score?
Z-scores have to be 2 because that's as far as the
Okay.
z-score table goes. All right, I love you guys. The midterm is during class tomorrow. It's not a different time. That would be illegal. That would be evil. Midterm is during class tomorrow. Is everybody with me? If there's any teacher that is assigning something that's a time for you that is outside of the time they're supposed to be, they suck and they need to be reported, right? So I cannot set a time for something. That's why I give you such a wide range on the quizzes to find a time to do them. Anyway, sorry. So the midterm is during class tomorrow. Camera's on. All right. So I'm gonna create this study group for tomorrow at 10:30, and you can come in, or you don't have to be there right at 10:30. You can come in after that if you want to. And then of course we'll have some time before we start the midterm tomorrow to ask questions. Yeah, of course. What's the only thing you can't correct for more points in this class?
The final.
Fine, exactly. So when you do the midterm, you'll be able to make corrections just like on the quiz. That's crazy. Yeah, okay, that sounds good.
When we make corrections, do we get full credit for it, or is it like half credit?
Oh,
When we make corrections,
so what's that one shirt that I want that I don't have?
read the syllabus.
So there's a whole section on correction. So if you get an 80 or above, you can get 5 points back max. If you do all the corrections, get them all right. So if you get an 88, you can go up to 93. If you get a 98, you go up to 100. You can't go over 100, too bad. If you get below an 80, you get 1 point back for every 4 points you missed if you do all the corrections and get them all right. So if you got a 68, you missed 32 points, divided by 4 is 8. You could get 8 points back on top. If I get any inkling that you copied from somebody else, and I always appreciate it when my cheaters cheat off a different version of the quiz. That's always funny and sad at the same time. Do you understand what I mean? There's different versions of the quizzes. There's different versions of the midterms. And so sometimes I'll get corrections that's from a quiz that's not even their quiz. And I'm like, oh, well, that was easy. Sorry. So if you're going to cheat, make it hard for me, put some work into it. Yeah, I'll send out the link for the study group tomorrow. Don't worry. I think that's what you're asking for, right, Melody?
Yeah.
So there's a link for the study group tomorrow, and then there's just the normal class link that's going to be for class. And that'll be, the midterm will happen during class. All right, guys, I'm going to call it so I can go get ready for this meeting. And I'll see some of you guys tomorrow at 10:30. So look in your email for the Zoom information for that. Otherwise, I'll see you at 12:30 or 1 for, 1 or 1:30 for office hours or the class.
Thank you, Professor. See you tomorrow.
See you.
Thank you, Professor. Really.
Sure.
I really appreciate it.
Oh, sure. Can you see it? Somebody's asking for a picture of that. Is that all right? Is that better?
Yeah, I finally figured out what I was doing wrong. I was plugging in, I kept doing the 24 and then C22, and then I put 0.88 times up to the 23, and then 0.12 up to the.
Oh, yeah.
Yeah.
Okay. You got to change everything. Yeah.
Yeah. I finally realized I was like struggling with that for like 15 minutes, and I'm like, okay, what am I doing wrong? And then I realized, oh, yeah, okay.
Wait, so what were you doing wrong? Because I'm getting 24 math. Oh, shit. 24 NCR 22, and then when I hit over, nothing happens.
You can't hit over on certain calculators. His
All right,
calculator is different than ours.
Billy, does it say NCR in your calculator?
Yes.
All right, so you only have to hit the over button if you are in the subscript or if you are in the superscript, right? So your calculator is a little bit older, and it doesn't have a big C with subscripts.
Right.
Does that make sense? So you don't have to hit the over, but I think your exponents are up, right?
Yeah.
Yes.
So then you have to hit over after you put an exponent in, so you come back down.
Got you.
But you don't have to hit over for the C because it's not a C. It's just put it in one. Yeah.
So it's 22 times 0.88 to the 22nd power.
Well, all right. So 24, choose 22 times 0.88 to the 22nd times 0.12 squared. Yeah.
And then once you get, and then you add up all three of those numbers, and then just subtract them from 1, and then you'll get your answer that you're looking for, right?
Yeah, because together these are the opposite of the question. So then
Gotcha.
I add up and then subtract it from 1.
Okay.
The question.
And you said that was going to be on the midterm?
Yeah.
Or something like that? Yeah. Okay.
Yeah.
All right. Thank you. Have a good day.
All right. I'm headed out, guys. I gotta get ready for this thing. I'll see y'all tomorrow.